One of the big limitations of arrays is that they are a fixed size. Well, C++ offers another data type that is like an array. It's called a vector. It holds a list of values or elements. If you're familiar with Java, vectors are very similar to array lists. But the advantage to a vector is that it's not a fixed size, and the values can be added and will automatically increase in size. To use a vector, we add the vector directive. When creating vectors, we can create vectors that are empty. We can create vectors that have an initial size. We can also create vectors that have an initial size and initial value for each element in the vector. We access vectors just like we do with arrays. We use subscripts. Let's take a look at my example here. I'm creating 3 vectors. The first one is an empty vector, and it contains car VIN numbers. The second vector is an integer vector that contains 10 random numbers. The third vector holds prices for 5 items that are initially set to 0. To make our program more flexible, I'm going to define a variable called numCars. That way the user can tell me how many cars are in the showroom. I'm going to use that value to loop through a for loop and ask the user to enter the VIN for each of the cars, and then I'm going to put them into my vector. How many cars are in the showroom? The user enters in the number, I read it into numCars, my for loop loops through numCar times. I ask the user to enter in the VIN for car. Notice I did I plus 1. This allows the user to see enter the VIN for car 1, but we know that actually the value is going to be stored in position 0. That's a little confusing to some people, so it's easier if you can say I plus 1 and then store it in position 0. I read in the VIN number. When you're adding a variable to an empty vector, you have to actually use the pushback command. So carvins.pushback, and in parentheses, I give it the value that I want to add. It automatically adds it to the end of the vector. Just so we can see how it works, I'm going to go ahead and print the VINs back out again. Notice that I can use the notation similar to arrays when I print them back out. Cout, less than, carvins, bracket I, bracket. Next, I created an array of 10 integer items. I'm going to go ahead and fill it with 10 random numbers. I use the random number generator, and inside my for loop, I say num bracket I bracket, similar to an array. I can use this value now because I already declared my vector to have 10 values. If it was empty, I'd have to use the pushback command. So here I have num bracket I bracket equals rand. It's going to generate a random number. And then I'm going to print the random numbers back out again. Other vector functions include .at, which returns the value located at element 0, .capacity, which returns the max number of elements, .popback, which is used to remove the last element from a vector, .clear is used to clear a vector of all elements, .empty returns a Boolean variable that will be true if the vector is empty. And finally, there's a .swap that you can use to swap one vector with another. Let's run our program and see how the vectors work. I'm going to put 5 cars in the showroom, and I'm just going to give them random VIN numbers. You can see that each time it prints enter the VIN number for car 1, car 2, car 3, car 4, car 5. Again, that's easier for the user to understand. Okay, when I print enter, the rest of my program ran, so if I scroll back up a little bit, here are the 5 VIN numbers that I entered and are stored in the vector. Next, I printed out the 10 random integers that were created and stored in the integer vector for random numbers. And finally, my Boolean statement says the vector num is empty because I used the .clear before I called the isEmpty function. As you can see, vectors can be useful if you know that you have to increase or decrease the size of the number of variables you want to store.